Now we're going to take a look at matrices. Now you've done matrices in the 9th grade. You did them again in the 10th grade with Mr. Thompson, so you're familiar with them. Matrix is nothing but an orderly way of keeping track of data, rows and columns, just like you make a table in Word or you use an Excel spreadsheet. It's the same thing. Okay, you do the same thing with matrices that you do with your kids. If you want to tell them apart, you give them a name. And here I've given this matrix the name M. And we usually use capital letters for matrix, and we reserve small letters for numbers. So this is matrix M. Another way of naming them is to use the M subscripted with a 2 times 3, or 2 by 3 more correctly. And what you're doing is you're telling whoever's looking at this that this matrix contains 2 rows and 3 columns. It's always row first, column second. So the matrix is 2 by 3. It's got 6 elements. The numbers inside the matrix here are called elements. Your calculator in your book will put the matrix name inside the matrix brackets. I'm not used to doing that. You can do whatever you like. Now in this diagram, I've numbered the rows with the blue numbers, row 1 and row 2. Number the columns with the red numbers, 1, 2, and 3. If I want to find an element in the matrix, if the matrix is named capital M, elements are named small m, and each one of them is given an address. So here you see a 2, 3. It means I want the element that's in row number 2, column number 3. So I go up to row number 2, column number 3, and a -5 is right at the intersection. So little m, 2, 3 is -5. And I found my element. Okay, now we're going to take a look at a couple of different applications of matrices. This comes from the 10th grade. You did this with my little bald compatriot. You've got a parallelogram up there that's got the vertices A, B, C, and D. And right next to the vertex is the ordered pair that goes with the point. Now in the matrix down here right below the picture, the row that's labeled X right here is for the first coordinate of a point. The row that's labeled Y is for the second coordinate of a point. The columns are the names of each individual vertex. So if I want to know the coordinates of vertex A, that's this column right here. The X coordinate would be a 1. The Y coordinate would also be a 1. For B, the X coordinate's a 7. The Y coordinate's a 1. For C, the ordered pair is 8, 4, and D, the ordered pair is 2, 4. And you've done, like I said, you've done that before in the 10th grade with Mr. Thompson. If you want to look at how it's done right now, you pause the video and take a look at the diagram. The next application you did in the 9th grade also, and I think we did this with Reebok, Nike, and Fila. On a small island, there's 3 types of bathroom tissue: rough stuff, clean sweep, and tender tushy. The islanders buy 1 roll on Monday each week. 75% of the people that buy rough stuff are going to buy it again. 15% switch to clean sweep, and 10% switch to tender tushy. Now, 60% of the people that buy clean sweep are going to buy it again. 20% of those people are going to switch to rough stuff, and 20% to tender tushy. Finally, 50% of the people buy tender tushy are going to buy it again. 30% switch to rough stuff, and 20% switch to clean sweep. Now, all this information is recorded in this diagram right here. The diagram is called a transition diagram. Now, if you look at the vertex that's labeled R right here, you see this closed loop that's labeled 0.75 tells you that 75% of the people that buy rough stuff are going to buy it again next week. If you follow this edge that goes from R to C, it tells you that 15% of the people that buy rough stuff are going to switch to clean sweep. And you follow this edge that goes from R to T, it tells you that 10% of the people that buy rough stuff are going to switch to tender tushy. And you can take a look at the problem and take a look at the diagram and see how it's made. And again, if you need to, You just pause the video, take a look at it, and see if you can't figure it out. Now, what you saw in the 9th grade is the matrix down here that's called a transition matrix, or I think in 9th grade we called it a brand switching matrix. It does the same job that this diagram up here does. If you look at row R, again you notice this is the left-hand side of the row side is from, and the column side is to. And again, it's always row first, column second. So if we're going to go from to, the from side has to be the row side. So if you look at row R, and you go to the 0.75 right here, that's the element in row R. It's in column R. It tells you 75% of the people that buy rough stuff are going to buy rough stuff again. If you look at row R in column C, right here, that tells you that 15% of the people that buy rough stuff are going to buy clean sweep next week. And row R, column T, tells you 10% of the people that buy rough stuff are going to buy tender tushy next week. And you can do exactly the same thing for row C and row T, and you've got the relationship between the transition matrix, the transition diagram, and the problem that created them. Now that'll take you through set 6.1.